All right, so now that we have discussed the idea of hypothesis testing and the p-value approach, we'd like to consider a few examples. All right, so the first hypothesis test procedure we will discuss is how to perform a hypothesis test for a one population mean. As we're going to realize, there will be two types. The first one is what we're going to call a one mean z-test. Right, so the one mean stands for the fact that we're performing a hypothesis test for one population mean. Right, so in order for the one mean z-test to be valid, the following assumptions must be met. The first one is that the sample we are working with should be a simple random sample. All right, so the sample should be simple random sample. Again, now let me remind you, the idea here is we are trying to use information we're getting from a sample to make inferences about a parameter pertaining to the entire population. So we're going to use statistic from a sample to make inferences about a parameter of a population. So the sample we should be working with is a simple random sample. The other assumption is that either the population should be normal, all right, so the entire population should be normally distributed, or we should have a large sample. All right, so large sample means n should be bigger than 30, all right, so our sample size. And really, we want this because we want our sampling distribution to be approximately normal. And remember, by the central limit theorem, the sampling distribution of the sample mean is approximately normal for large enough sample sizes, or if the population is normal. All right, so we talked about this situation in class when we had a sample size that was moderate, let's say between 15 and 30. Then in that case, what we would need to do is we would need to see if the data was normally distributed or not. And to do that, we used StatCrunch and we looked at the QQ plot. All right, however, if we have a normal population or a large sample, we're good to go. And finally, the fact that we're using a z-test is because we know the population standard deviation. All right, so the third requirement is that the population standard deviation, which is sigma, be known. All right, so simple random sample, we want the entire population, whatever we're looking at, to be normally distributed, or if it's not normally distributed, we'd need a large enough sample. And finally, we would want to know the population standard deviation. All right, so with that said, we are going to look at example 2.1, and this is the example we're going to use to motivate this discussion here. All right, so a bridal store claims that the average cost of bridal dress in 2019 was $1,750. And what we did is we went outside and we collected sample of 20 brides who bought their wedding dress in 2019. We know the cost of bridal dress is normally distributed, and the standard deviation of all bride dresses in 2019 was 180. And what we did was we took the data and we collected the data. Those are the 20 responses for brides that bought their wedding dress in 2019. To produce a histogram and a box plot for the data. All right, so what we're going to do is we're going to go to StatCrunch. All right, so StatCrunch. And we are going to log in. I'm already logged in, but I'm going to go to my groups. I'm going to go to the center group here, and I'm going to look at the data sets I have, amongst which is the bridal dress cost 2019. So that's the one I'm going to open. And that data set here contains all the responses that we have on our handout there. So those are the 20 responses from the brides who bought their wedding dress in 2019 and how much they paid for it. So what we would like to do is we would like to see how we can use StatCrunch to create a box plot and a histogram for this data here. So let's start with a box plot. So we're going to go to Graph. We're going to go to box plot right there. We are going to sketch cost. I want to draw the boxes horizontally, and just I would like to see what the mean and median look like there. All right, so far what we did is we went to StatCrunch, we created boxplot. We're gonna sketch the cost, and we're gonna do that. So that's what the boxplot looks like. All right, so next what we're going to do is we're gonna look at a histogram for this thing here. So let's go ahead and sketch a histogram for the same data. Again, we are going to do a cost. All right, so next for this one here, rather than doing frequency, I'd like to look at the relative frequency. And finally, there's this option of bins here. All right, so it's this bins option here. What I would like to do is I would like to look at the smallest value here in our box plot, and I realize the smallest value here is 560. So I'd like to start my bins at 500, and I'd like to look at the width. So what I'd like to do is I'd like to group the data here, and the groups, each of them are going to have class width 200. All right, so there's a lot of stuff you can play around with. All right, but right now that's what I'm going to do. I'm going to compute it, and that's what the histogram for that data set looks like. All right, so again, when I went to the histogram here, I started the bins at 500 because I realized the smallest value was 560, and I wanted to group them with 200. Again, this was my own choice. I could have done 300, for instance. You could have picked different ones. All I wanted to do is get a sense of the data there. All right, so again, StatCrunch is going to be our friend. It's going to save us a lot of computation, and visualizing data, generally we are going to resort to StatCrunch to do that. All right, so let's go back to our worksheet here. So we use StatCrunch to produce the histogram and box plot. And now what we need to do is we want to calculate the average from the sample. All right, so what we're going to do is we're going to go back to StatCrunch here. Let me close that. And what I'd like to do is I'd like to find the average of this data here. To do that, we are going to go to Stats. We're going to go to Summary Stats, and we're going to do it by columns because our data is arranged in a column. So I'm going to look at cost here, and I'm going to ask StatCrunch to produce all of them, even though we're probably not going to use all of them, and we're going to compute them. All right, so the things I am going to be interested in is I'm looking at the mean, and I'm looking at the count, which is 20. All right, so let's go back to our handout again. All right, and give me 1 second. Sorry. So when we looked at our average from our sample, we realized the average was 1667.5. All right. So this is the average of our sample. Sorry. This is the average from our sample. And so the question is, what is the symbol we use to represent this average? Is it mu? The answer is no. The symbol we use to represent this average is x bar. Remember, because we are finding the average of a sample mean. So in this case, from StatCrunch, we know the sample average is 1667.5. All right. So there are two questions here. What symbol do we use to represent 180, and are all the assumptions of a z-test satisfied? So we're going to go back to our question there and read the question here again. All right, so let's go back. We know we have a random sample, we know it's normally distributed, and we know the standard deviation of all bridal dresses in 2019 was 180. So the standard deviation of all of the bridal dresses in 2019 was 180, means we know the population standard deviation of the price of bridal dresses was 180. And the symbol we use for population standard deviation is sigma is equal to 180. All right, so now before we proceed with the z-test, we need to make sure that the assumptions are satisfied, right? So that if we want to do a z-test, we want to make sure the assumptions are satisfied. So the first assumption was that the random is simple. Sorry, the random so the sample is random. All right, so random sample. Sorry. The second assumption was that the price of bridal dresses is normally distributed, and that was given to us. So the price of dresses were normally distributed. We are given that information, and the final thing we need to check is whether the population standard deviation is known or not. And remember, this is because distributed. All right, and this is because if we want to use the z-score, we need to know the population standard deviation, and in this case here, sigma is known. All right, so with all of that being said, now we are going to move on to doing a hypothesis test. All right, so we are going to work with a two-sided hypothesis test, and the question is, at 5% significance level, does the sample data lead us to rejecting the hypothesis that the population mean of bridal dress in 2019 is 1750? All right, so the question is, based on our sample, which gave us a mean of 1667.5, and we know the population standard deviation is 180. At a 5% significance level, can we reject or not reject the null hypothesis? The null hypothesis being that the dress is the mean, population mean for bridal dresses is 1750. So really at the heart of hypothesis test for anything, but in particular for population mean, all right, one population mean is the following. We got a sample whose mean was 1667.5. So the question is, where does our sample mean of 1667.5 fall in relation to all other sample means in a sampling distribution of sample means? All right, so if we take all possible random samples, we find the means of all of these samples and draw a distribution chart, where does the sample mean of 1667.5 fall in relation to all other sampling means? So that's the question. But for now, we're going to go ahead and we're going to state our null and alternative hypotheses. So the null hypothesis, H0, is that our population mean is actually 1750. All right, so we are starting with the assumption that our population mean, so let me just write this in Word. So the population mean of bridal dresses in 2019 is 1750. All right, so that's our null hypothesis. That's what we're going to start with. And the alternative hypothesis is that our population mean is different from 1750. So is that a two-tailed or a one-tailed? So it's going to be a two-tailed. All right, so if we are looking at this question here, we want to specify what the significance level is going to be. All right, so were we given what the significance level was in this question here? We were told to look at it at 5% significance level, so our alpha in this case is going to be 0.05. So the third step is, what we would like to do is, since we're doing a one mean z-test, we would like to find the z-value corresponding to our sample mean, or we're going to compute the z-value test statistic here. So the formula for z-value is going to be x bar minus mu naught divided by sigma over radical n. All right, so in this case here, our x bar, which is our sample mean, is 1667.5. Our mu naught is 1750. Right, our population standard deviation is 180 divided by square root of 20, And if I plug this into my calculator, and you can go ahead and check this, please make sure you check all of my work. And if you find any mistakes, please let me know. 0.49729. But our z tables are in 2 decimal places, so this is going to equal negative 2.05. All right, so what this says is if our population mean is 1750, which is our null hypothesis, this is saying our sample mean of 1667.5 is 2.05 standard deviations away from the sample from 1750. All right, so that's the test statistic. So now, remember, we are trying to find the p-value. P-value, again, is the probability that we, So p-value is the probability of getting a result like the one we did, provided the null hypothesis is true. All right, so that's what we're trying to compute here. We're trying to compute the p-value. So remember first, the test is two-tailed here. So we are doing a two-tailed test. So what I would like to do is I would like to draw a picture of what we're interested in. So we have something that's normally distributed. Since this is a two-tailed test, the p-value is going to be the probability of observing something that's less than negative 2.05 or something that is greater than 2.05. All right, so since this is a two-tailed, the p-value is the probability of observing a value of z that is less than negative 2.05 or is greater than 2.05. So we are interested in the sum of these two areas here. So if we want to find this area, we're going to look at the z-table. Sorry, I don't have that loaded up. But if you look at the z-table for value z is equal to negative 2.05, you should see that the area on the left of negative 2.05 is 0.202. All right, so the area to the left of negative 2.05 is 0.0202. So in this case here, then, the p-value in our example is going to be these two areas, which is 2 times 0.0202, and this becomes 0.0404. So that's the p-value here. All right, so now once we have our p-value, what we would like to do is we'd like to compare our p-value with alpha and determine whether we're going to reject H0 or not reject H0. So in this case, since p, which is 0.0404, is less than or equal to alpha, since the p-value is less than the significance level, what we're going to do is we are going to reject H0 in favor of HA. All right, so the p-value is less than our significance level. All right, so that's, we're going to reject H0. So in the context of this question here, and whenever we do a hypothesis test, we're going to run all that, but at the end, I want you to interpret your result in the context of what we were asking. Remember, we were asking whether at 5% significance level, the sample that we had could lead us to rejecting the hypothesis that the population mean of the cost of bridal dress was 2019 was 1750. So the question is, since we show that our p-value for that given sample was less than our significance level, we rejected H0. So in the context of this question, it means at 5% significance level, the data provides sufficient evidence conclude that the population mean of bridal dresses in 2019, so the population mean of bridal dresses in 2019 was different than 1750. Alright, so what we've managed to do is, since our p-value was less than our significance level, less than or equal to, we were able to reject H0 in favor of H alpha. Alright, so that's this example here, but while I have your attention, what I would like to do is I would like to run through this example on StatCrunch. Alright, so we're going to do this on StatCrunch here. So, alright, so let's go ahead and let's go to StatCrunch. Alright, so we already have this loaded here. So if you don't have these data loaded, what I would do is I would go to StatCrunch, I'd go to my groups, I'd go to the group you're in, and we're looking at bridal dress cost, and you should have that spreadsheet up here. So again, remember we are doing a one mean z-test, so we're going to go to statistics here, we're going to go to z-stats, we are looking at one sample, and we are going to use data. All right, so we're doing it with data. So the data we are using is the cost. We know the standard population standard deviation. The population standard deviation given to us is 180. All right, so next we are going to perform our hypothesis test. The hypothesis test, our null hypothesis, was that our mean was 1750, and our alternate hypothesis was two-sided, so mu is not equal to 1750. However, if you had left-sided or right-sided, you could change that. Again, after you answer each question on your homework or on your quizzes, what I'd like you to do is I'd like you to verify your answer using StatCrunch. Why not, right? And then what I'm going to ask StatCrunch to give us along with the information is I'd like to find a p-value plot. Right? So it's supposed to look like the terrible picture I drew on the handout earlier. All right, so again, we are going to use the cost here. Our standard deviation is 180. We're running the hypothesis where our null hypothesis is mu is equal to 1750 and our alternative hypothesis is mu is different than 1750. Again, running a two-tailed test here, two-sided test, and we're going to ask StatCrunch to give us a p-value plot as well. All right, I'm going to go ahead and I'm going to compute. And if we do that, we know what our sample mean was. Our z-stat, as we calculated, was negative 2.049729, which was roughly negative 2.05, and our p-value was 0.0404. All right, so that's exactly what we had earlier. Next, what we're going to do is we're going to look at picture here. All right, so the picture here is telling us our z-value is negative 2.049729. So we're going to look at the area to the left of negative 2.0497 and to the right of positive 2.0497, and our p-value is going to be the sum of those areas. So in that case, since there's 0.0202 on both sides, the p-value is, in this case, going to be 0.0404. All right, since our p-value is less than our alpha, 5% significance level, so it's less than 0.05, we're going to reject H0. So in this case here, what we have shown is our results are statistically significant at 5% level. Right? So they're significant in that they provide sufficient evidence to reject the null hypothesis in favor of our alternative hypothesis. So in other words, the data provides sufficient evidence to conclude that the population mean of bridal dresses in 2019 was different than 1750. All right, so that's it for this video here. Next time we're going to talk about how to do a one mean t-test.